Now, before we move on to the next two examples, let's go back to this table and think twice about what this table is telling us. Well, in fact, in this table that you can see over here, there are three cases for you to solve homogeneous second-order differential equation based on the characteristic equation. And on the right column, this is the general solution for each and every case, where a and b are always some constants. So our next question would be, is it possible to find a particular or exact solution for a given problem? The answer is yes, and we'll see how this works out by looking at the next two examples. Okay, let's move on to example 3. Find the particular solution. So pay attention to this question. Now we need a particular solution instead of a general solution. To the differential equation, 4y double prime minus 9y prime equal to 0. And besides this given equation, you're also given two conditions. One is the value of y when x is equal to 0, which is -1. The other condition is the value of y prime when x is equal to 0, which is equal to 1. So in fact, we'll be using these two additional conditions to solve the particular solution for this equation. In order to do that, we'll find the general solution first. So again, we'll start with writing down the characteristic equation, which is 4 lambda squared minus 9 lambda is equal to 0. I have two terms here, both have lambda involved, so I can take it out, which gives me lambda times 4 lambda minus 9 is equal to 0. Then we can solve the value for lambda. There are two values for lambda. One is equal to 0. The other one is going to be 9 over 4 based on this equation. So we get two real values for lambda. Remind yourself which case we're dealing with. Let's go back to the table. Apparently, we're dealing with case 1. Okay, so for case 1, the general solution is in this form. Let's write it down. So therefore, the general solution is y equal to a times e to the power of lambda 1x, which is 0 times x, plus b e to the power of lambda 2x, so 9 over 4x. And the first term, apparently e to the power of 0 is always 1. So we have a plus b times e to the power of 9 over 4x left. So this is the general solution for this given homogeneous second-order differential equation. And now we're going to use these two given conditions to figure out what are these constants a and b. Now, since y of 0 is equal to, now you have the expression for y. In order to find the value of y when x equal to 0, we just sub in the value of x to be 0. So it's a plus b e to the power 9 over 4 times 0, which is a plus b. And this one, if you look at here, is -1. So that's the first condition that we just used. Now, second condition gives us the value for y prime when x is equal to 0. And in order to use it, we have to know what is y prime. How do we find that out? Well, we start from here as well. You have the general solution for y. Then, by taking derivative of this y, we can find y prime. So a is a constant. When you take derivative, it will become 0. The second term, when you take derivative, b is a constant, so b stays. And for this exponential function, when you take the derivative, 9 over 4 comes here, and another e to the power of 9 over 4x followed. So what is y prime of 0? You sub in the value for x equal to 0, I'll get b times 9 over 4, which should be 1, according to the given condition. So now we actually end up with two equations over here involving a and b. Can we find the value for a and b now? Yes. Well, from equation 2, it's not difficult to tell that the value for b is 4 over 9. And then you bring back this value to equation 1 up here. You can solve a, which is negative 1 minus b, which is negative 13 over b over 9. Okay, now we have found both values for a and b. That means we have found the particular solution to the given differential equation. So the particular solution is y equal to, once again over here, a plus b times e to the power 9 over 4x. And we're going to plug in the values for a and b. Negative 13 over 9 plus 4 over 9 e to the power of 9 over 4x. And we're done. So this is actually the general steps for you to solve any questions in this form. We are asked to find the particular solution of a differential equation. First, you need to find out the general solution, and of course there will be constants involved like a and b, and then you need to use the given conditions in the question to solve what values a and b are in order to find the particular solution.